So apologies for losing the first bit of video on this. I didn't actually start the camera recording, and so I'll recap here. Quite some time ago I ended up with this, actually with another scope like this, and so I've ended up with two of these scopes. This one I acquired yesterday, and I've started to do a partial teardown here just to take a look at it internally. This one works. It powers up. I did some quick tests. Both channels are there. The triggers work. What I see on the screen seems reasonable. But mechanically, it's just been beat. You can probably see here the bending in the frame here. It's been dropped, and the shaft for the veneer adjust here has been broke off. This BNC jack is busted. The scope's just been beat up. It was dropped on this back corner. The legs all bend in. It's just physically been beat, even though electrically it looks good. I have a second one, same model scope, that physically is in great condition. The skin, the skins, the chassis, everything's in great condition, but it looks to me like the front end on that one's been blown out. It acts really odd to input signals. It may be as simple as just a failed cap on the board, or it may be something much worse on the front end. And so I've been debating about either transplanting the working boards from this one into the other scope. It really depends on teardown here, and that might be possible. Or substituting skin pieces from the other scope onto this one. And of course, this entire backing plate here would have to be replaced. There's a lot of actual physical solder connections there that have to be broke loose to swap this plate out. This front plate wouldn't be as bad. The other option that I'm considering is simply taking the front end board out of this one. I might have to do a bit of work to replace these rotary switches with the good ones, at least what I believe to be the good ones from the other scope front end board. And the idea between the two is to get a functional analog scope. There are times that I personally find a Crow style scope is really best for the work you need to do. I've got a really nice digital scope. It's really an excellent tool, but like in XY mode, I just find it very lacking. I'm not happy in XY mode on it for the things I want to do. And of course, the persistence on the CRT here is what makes this work so well in XY mode, whereas you know they try to emulate it in software. To me, it doesn't emulate really well. So I started to tear this down before while I was talking, and then realized I hadn't actually started the camera, which is why I'm trying to kind of recap here. I think at this point my goal is to get this front end board removed and out, and then do the same thing on the other scope and begin looking at what it might take to meld the two together. I spent some time looking for the proper Allen wrench for these knobs, and the Allen wrenches I have laying around here are SAE, and it looks to me like these are probably metric, and I can't find my actual good set, and that's a little bit too small. This is probably going to be a little bit too large. A Allen wrench is just to break these knobs loose. Nope. Okay, that worked. So there's probably 2 Allen screws on this, and there are 2 set screws. Both set screws are loose. There's going to be 2 on this guy as well. So at this point, both are, well, not all the knobs. I've got other knobs I could pull, but they really aren't part of this board. There's no set screws on that knob. I'm sure it just pulls off. I don't see any set screws on that knob. If we just need a bit of persuasion, yeah, that's all he needed. Well, anyhow, we're at this point. I'm going to go ahead and break these nuts loose. and we'll go from there. Get these bits back in their little holder here. Back up on a shelf so I don't lose them. I probably should be using a socket for this, although this pair of wide pliers here are just fine for getting in there and loosening up the nuts. Yeah, this scope has just not been treated well. You know, evidence of at least 2 drops. I suspect more than that, just based on how many dings and dents there are in it. Yeah, get the washer to walk off there if I can. And this washer to walk off down here. And at this point, that board is loose. I've just got to remove this connector. Of course, it doesn't want to come off. Let's see now if it's possible to just kind of walk him loose. Given how bent up the sheet metal is, that's proving to be a little more difficult than perhaps it should be. Work all these cables out of the way. They're getting stretched a bit. Let's see if I can, actually he goes down around this way. So we've successfully removed this board. You know, really the missing shaft and the bent shaft here appear to be the 2 issues with it. And looking at this shaft, I think there's a little C-ring down in there. This shaft's completely missing down to that pot. Yeah, there's a little C-ring over the end there. That with that C-ring removed, I'm sure that shaft would pull out. It'd be a tight spot to get the little C-ring back into. I'll have to think about how to approach this. But maybe the first step is just to simply substitute this board in on the other scope and see if that solves the front end issue on it. Little contact cleaner in these, I think, is warranted. I may be able to actually just flex that shaft back straight with a little mechanical persuasion. Well, let me set this guy aside, and we'll bring up the non-operational one. This is the one that I believe has had front end damage. But mechanically is in reasonable shape. And we'll take a look. I know I opened this up before and I didn't see any obvious signs of damage. on the front end. You know, the sweep, all those kind of functions seem fine. It's just the waveforms are horribly distorted. And there was just really no way, you know, tweaking that I could find to clean them up, which to me indicates front end damage or bad capacitors, or, you know, any one of a potential myriad of things. So there's the bottom removed from this one. And the front end boards are actually, well, no, they're not substantially different, just the components are different. So it's got larger physical caps, these are smaller. The switch assemblies are the same. This, whatever this network here is, let me make sure we're still recording, and we are. Whatever this guy is, I thought it was a thin film network of some kind, but I'm not convinced that's what it is either. It almost just might be some shielding. It's attached to what looks to be a ground trace in 3 places. That may just be an attempt at some shielding between channels, honestly. Board's a little warped, but that's typical of these phenolic boards. Again, looking at this guy, I don't see any, you know, physical signs of damage. And of course, like I said, I could sit with the two of them side by side and feed them both the same signal and kind of probe my way through. See if I can identify what's failing in this one. And the issues may be deeper there than on the front end board here. I'm looking at the board, I'm looking at the connectors. They are completely consistent. Looking to see PFE 55 9E, and this is a PEF 559. So there are different revisions. But you know, they're labeled similarly in the silk screen. Everything's in the same locations. You know, there's been some kind of engineering change, whatever it was. Doesn't guarantee this board will plug in and even work in this scope. I may make things far worse here. But that screwdriver's not going to break him loose. I think that's going to be too small, or not. Nope, I'm going to end up stripping these. Wow. So the screwdriver I need vanished some time ago. I'm going to have to go locate it. That shaft's actually slightly bent as well. But we can kind of keep working down through here. I'm sure that doesn't have a set screw in it. Doesn't. It's just on there very stiff there. Work loose. Hopefully I'm getting at least some of this on camera. Pull off those same two knobs with the set screws. Yeah, I was actually surprised this scope even powered up. It is absolutely beat. Or the other one is absolutely beat, you know, mechanically. Just has not been taken good care of. It came from an estate sale. I believe another ex-Boeing engineer who's passed. The guy running the sale claimed that all the electronic stuff was tested and working, and I kind of look at that and went, huh, really? Did this one not? There it goes, okay. Just given the condition of some of the stuff that came out of there, I didn't myself make it to the estate sale. A friend did. She sent photos. She actually picked up the other scope. That mechanically just beat into the ground, and like I say, I was really surprised to see it actually produce trace and seem to operate overall. So I'm going to have to find the proper screwdriver to break those Phillips loose. But I can keep mumbling here while I do this part of the teardown. So there is a definite difference here in the construction. There's no locking washers on these pots, and the metal bezel has smaller holes here where, you know, maybe not. It just hasn't been broke loose through mechanically everything being bent. So I'll pause the video here, track down the proper screwdriver to break these Phillips loose, and I'll be back. Okay, did a bit of digging. Found a screwdriver that should be the correct one. It matches with the Phillips head. Not too small, not too big. And of course, the proper tool, where these seemed incredibly tight. Actually, is working them loose pretty easily. It is requiring a bit of downward pressure to keep from stripping it, but generally, oh, and then I dropped the screw down inside. Always got to drop a screw down inside of anything you're taking apart. Hopefully I can you can certainly hear it rattling around in there. Crap. Excuse my French. I'm going to have to pull the other skin off here to get that screw out. Never fails. Always drop a screw down inside. It just wouldn't be fun and entertaining if you didn't. Looks like this was last calibrated 1986. This little guy's been around for a while. I am sorting the hardware in bits and pieces from this one to the left-hand side here, just to kind of keep everything separate. Although I didn't do that for the legs. That screw's already been removed. This over. Releases the little storage bag. Let's see if I can get him to lift up off of there. hopefully that screw will just kind of fall out here. Oh, I thought I'd removed the battery pack from this one. I actually hadn't. I've got two of these battery packs. There it is. Good. The lost screw has been removed, or has been found and removed. Let's unhook the connectors here. If I can get them to pull loose. I'm not horribly worried about calibration. I think I said this a minute ago for what I'm going to do with this scope. You know, high accuracy calibration just doesn't matter. It's more about mostly being able to use it in XY mode. So everything should be loose here. We should be able to hopefully walk this board. Oh, got another cable. Walk this board up out of here the same way we did the other board. Kind of fishing the cables out of the way as best we can. I don't believe I'll have an issue getting these back on. They're pretty, the lengths are pretty specific to where they mount to. If not, hopefully the video I've shot will give me enough guidance. So, we've worked this board loose. The shaft I'll need to salvage. Anyhow, there's the two boards. Don't know if I've got them both in frame here or not. I'm going to substitute this one into the scope that everything else was functional on, with the one that's in better mechanical shape. I'm going to substitute it into here first and just see if we can actually get a good trace and inputs that actually seem to function. So all I want to do is kind of walk this into place. The cabling on this is of course tight, and the clearances are pretty narrow for getting around stuff. All I should need to do at this point is route these into where they need to go. Put a couple of screws back in, connect everything up, and hope magic blue smoke doesn't come blowing out of the thing. Why is that sitting high over there? Just there's that piece of black foam under there that kind of holds everything tight, and that's why I think the boards are bent, is they're actually being kind of compressed down onto that foam. Actually, that's not going to work. I've got to work those connectors through first. So this connector comes in from the side, and he goes right there. This guy, if I can get a hold of him, is here. This one's going to be a bit tricky because of that problem right there of him backing out of the way when you touch him. See if I can give him some persuasion to come through. Come on. Now I'm gonna have to back this screw out as well. Get a little more clearance here. And I believe I just dropped one of the screws on the floor, which of course is thrilling. You're on there. These two need to come through the little gap here. I have to say, mechanically, this is somewhat designed for service, but still it's fairly tight clearances. This guy is here. They've at least done enough to change the facing, unlike these two connectors, to make it very difficult to cross them. You're to there. This brings in one channel's input. This brings in the other channel's input. And not that I believe it's critical, but I'm going to go ahead and secure the board just in case there's ground. There's a couple of screws that kind of like bored into this bracket, and I just want to make absolutely sure that the ground, any ground connections are solidly made back to the case. So really we're free floating in there. I don't believe these mechanical connections up on the front matter. At least they're not super critical. In looking for the screw I dropped, and looking at how far the nuts drive on these, they don't drive super tight. So I think with that, I have enough confidence to bring in some power. Let's see, power is, where was power? Oh, it's the flip, a little switch right there. I was thinking it was a knob. Oh, excuse me. Hopefully we're not going to see magic smoke. Well, we have a power LED. Let's see if I can find a trace. There's one trace. The position is there. Let's get it channel 1, channel 2. There's channel 2. We'll go ahead and alternate between the channels. Well, let's feed this guy in an input signal and see what we get. I'm just going to, for now, input a few waveforms off of my waveform generator. We should be seeing a sine wave trigger to channel 1. Can I get it to trigger? Let's go back to just single channel. Why can't I get a trigger? I should be able to get a trigger here. See it kind of react, but not actually grab a trigger. That's not a good sign, since I think part of the trigger, trigger balance is coming off of the board we substituted in. So not seeing it grab a trigger is concerning. Auto, normal. Oh, we saw it. See it grab occasionally. Let's try channel 2. I may not have the connector on down tight to what I take to be the trigger output, and I didn't. That connector wasn't seated. Perhaps that was the issue with triggering. There it is. Okay, we're getting a good trigger now, so it was just a mechanical issue. So the real question here is dropping a square wave in, and that looks perfect. So on the other scope, the square wave destroyed it. The front end would collapse. It was just a nightmare, and on this it actually looks really good. I'm perfectly happy with that. Let's jump over to the other input. Go to channel 2, triggering on channel 2. Look for the channel 2 position. There it is. So channel 2, we can get a trigger on. So let me kick this up to 5 megahertz. Let's see what we get at 5 megahertz. Again, that looks okay. Square wave at 5 megahertz. There's some under and overshoot there, but again, I'm unterminated directly out of the function generator into the scope front end. But I'm not unhappy with that. Go back to channel 1. Well, I should put a couple probes on this and hit the calibration and see if we can calibrate it out cleanly. Nice little XY mode. Yeah, those are, where's the position? Yep, these seem reasonable based on the waveforms I'm dumping in. That's just going to be noise. The arbitrary has really nothing programmed in it. Arbitrary. Oh, I'm in help. That's why that looks funny. Arbitrary load. I've got some built-in waveforms. I believe that's a pulse. Come back to channel 1 only. What have I done here? There we go. Bring it down. Change the voltage a bit. If I can get a hold of the shaft. We will grab a trigger. See if I get one of these on screen here. I'm actually not triggering well on it, but that's fine. I don't know if you can see that or not, but there's essentially a little pulse train there to emulate a human pulse. Arbitrary edit. No, I don't want to edit. I want to load from the built-in. And we'll do an upward staircase. And that looks very reasonable. Yeah, I'm perfectly happy with the combination of the boards from the two scopes at this point. This will get me what I need. It's just a basic functionality analog scope. So really now the challenge is the mechanical repair on the shafts. And I think between the two I'm going to have a nice little scope. Sweet. So looks like this is going to be probably simpler than I thought. So of course the question ultimately becomes, what has failed on this board? Make sure I'm still recording. What's failed on this board that's causing the really weird behavior? And it's on both channels, which tends to lead me to it's something common. There's some TL070 or 071 op amps. There's a 74 LS74. There's a flip-flop sitting there. Probably toggles back and forth between the channels. Looks to me like it's all analog switching. Could be as simple as just these electrolytics, one of them or more has failed. And it might be worth trying to replace them. I'm having a hard time reading the value on them. The 100 microfarad, 25 volt. There's 6 of those. However, they seem to be, 3 per channel, and it could be that there's multiple bad ones just with age causing the issue. There's a couple more little electrolytics sitting out here. There's lots of solder flux on the board, so it's hard to look and say one of these caps is leaked. There's a group of 3 down here that don't look to be implemented over here. That's the same. Because both channels are affected, I tend to, as I just said, think that it's something common. But perhaps it isn't. I don't know if I've got any 100 microfarad, 25 volt caps. I would have to look. Looking in this scope, the caps aren't the same, which makes me think, at least 3 of them have probably been replaced over the years. It may be worth digging up a full set of caps for this and just recapping this board, since mechanically the board's in good shape. Like I said, this does definitely isolate this to this front end board being the issue. So I'm really tempted to go ahead and order up, either look in my stock for replacements or order up the ones I don't have. I don't know if I have 100 microfarad 25 volters. I would have to go look. Let me say, looking at this board, just because there's a different one sitting there, and he's much shorter. And there's two different ones here. I'm sure it wasn't manufactured like that. You know, all the caps here look like they're potentially the same manufacturer. It's hard to say. And these are, you know, shotgun mess. It's hard to say. As you've probably seen in the last couple of videos, I've not had a lot of luck getting things to work with capacitor replacements. Of course, both of those were switching power supplies. Looking to see how hard it would be to swap these switches, and it wouldn't be that hard. It might almost, if I decide to go that direction, it might be actually easier to swap the entire switch out than to attempt to just replace that shaft. Well, I'll give this some thought, and I'll catch you up in the next video segment. Bye.